Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is matrices. What you're going to learn today is how to form a transpose of a matrix. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the transpose of a matrix. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of the lesson Moses Funded, today I will explain and give you examples of another special group of numbers that are called the deficient numbers. I will explain what are deficient numbers after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me just first define the transpose of a matrix. The transpose of a matrix, for example, matrix A. It is usually denoted by a T. T is a subscript. Look at it here. This is the meaning of transpose of a matrix. And this is a matrix whose rows are exactly the columns of the original matrix. So the columns of the original matrix will now become the rows of the transpose of that very matrix. Or you can now say that the transpose of a matrix is now formed by exchanging rows with columns. So you can now exchange rows. Rows becomes columns or columns becomes rows. This is the meaning. Let's just have examples of matrix that we now find it is transpose. If you have matrix M, for example, and this are the entries in the first row, A, B, and C, and D, E, F in the second row. And if we are to form the transpose of this very matrix, we now said this rows becomes the columns, or this columns becomes the now the rows, whichever way you take it. So this will now have the matrix M. It is transpose, that is MT. T is a subscript, will now be equals to this very matrix. You can see here element in the first row. This first row will now be exactly this column of the original matrix. Second row will now be the second column of your original matrix. Third row of your transpose will now be the third column of your original matrix. Or if you now take this row of the original matrix, will now be the column of the transpose. Second row will now be the second column, whichever way you take it. Either you now say the rows of the first, that is rows of the original, becomes the column of the transpose, or you now said the columns of the original becomes the rows of the transpose. Whichever way you take it, all we need to do to find a transpose is to exchange rows by columns. We are going to take examples how we can now find the transpose of some matrix. So let us just move. Example number 1, it says given a matrix A. These are the elements in the first row, 2, 1, and 3. 4, 0, and the minus 1 in the second row, and the question asked is to find the transpose of this matrix A. Solution to this very problem, what we do first is to copy down the original matrix A. This is it. You have your matrix A with entries 2, 1, and 3 in the first row, 4, 0, and the minus 1 in the second row. Then the transpose of this very matrix, that is AT. AT, T is a subscript, will now be another matrix, new matrix. Let me write the entries in that very matrix. The rule says either this row of the original becomes the column of the transpose, or you can now say that the columns of the original becomes the row of the transpose, whichever way you take it. So this 2, 1, and 3, that is your first row, who now becomes the first column here. So you are now going to have 2, 1, 3. You now, that is first row there, who now become first column here. So I'm going to have 2, 1, 3. Then I'll take the second row of the original. That will give me the second column in the transpose. So I'm going to have 4, 0, and minus 1 as the entries in the second column. This is the transpose. It's as easy as ABC. And you can be asked this very question. Let's take one more example. Example number 2 says given that the matrix K has this entries for 0 in the first row, 3 minus 1 in the second row, 2 and 1 in the third row, and the question asks is to find the key t. T is a subscript. This simply means transpose of the matrix K. Solution to this very problem: copying down the original matrix K with the entries, and now attempt to find the transpose of that very matrix KT. So if I take element C in the first row of your original will now become the element in the first column. So element in the first row will now become element in the first column. Let me do that. So this 4, 0 would now be the elements in the first column here. Let me write it. And then the second row will now give you the second column. Let me do that. So 3 and minus 1 will now be this element in the second column, 3 minus 1. And the last, this element, the third row, will now give you the third column. So you are going to have 2 and 1. So you now exchange rows with columns. This is how we now find the transpose of a matrix. This is where I come to the end of this very lesson. My dear student, I hope with the few examples given, you'll be able to find the transpose of any matrix. Thank you for your attention. Let me just move to the last segment. It's fun, and I explain what are deficient numbers. So let me explain what is deficient number. A number is deficient if the sum of its proper factors is smaller than the number itself. Let's just take examples. So examples of deficient, you have 9 and 26. These are just two examples. If 9 is deficient, it means some of its proper factors will be smaller than 9. If 26 is deficient, which means some of its proper factors will be smaller than 26. But let's just confirm and see. So starting with some of the factors, starting with the 9, the proper factors of 9 will now be 1 and 3. Addition of 1 and 3 gives you 4, and you can see 4 is smaller than the 9 itself, which means 9 is deficient. Next is 26. Let me take 26. Its proper factors will now be 1, 2, and 13. These are the proper factors of 26, those numbers that can divide 26, no remainder. So if I add these three numbers, 1 plus 2 give me 3. 3 plus 13 will now give answer 16, and you can see 16 is smaller than 26, which means 26 is deficient. Other examples of deficient, you have 10, 11, 13, 14. All these are deficient numbers. We see more of these interesting things in mathematics